Unlike humans who need breaks, Tesla Bot Gen 3 can work continuously for 6 to 8 hours on a single charge. During that time, it completes over 150 household tasks without any drop in performance, thanks to a passive cooling system and a simplified drive mechanism. Its smart load balancing system also prevents joint overload, mimicking how humans naturally shift effort when working for extended periods. So, what is the real upgrade Tesla has made that allows the bot to work tirelessly for hours? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. Why can the Tesla Bot complete so many tasks in such a short amount of time? It's hard to believe the sight of a robot standing in the kitchen, gently pouring orange juice, toasting bread, and setting the table, all in under 20 seconds. But that's exactly what the Tesla Bot Gen 3 did in the 24 Hours Without Humans challenge, a once unimaginable scenario that's now a reality. What's truly astonishing isn't just what it can do, but how fast and precisely it performs each task. Many viewers were left saying the same thing. It works even faster than I do. The first reason lies in its incredibly compact and flexible hardware. Tesla engineered a humanoid robot with adult-like proportions, around 1.73 meters tall and weighing 56 kilograms, made from lightweight materials like aluminum alloys, carbon fiber plastics, and ultra-precise mechanical joints. Key parts like shoulders, elbows, wrists, and fingers can bend, rotate, and flex just like human joints. In total, the bot has 28 degrees of freedom, meaning 28 independently moving joints. Thanks to this, it can crouch, reach for a cabinet, squat down, walk through tight spaces, or gently hold a glass just like someone working in the kitchen. A major leap forward lies in its hands. Each hand has 5 independently moving fingers and tactile sensors at the fingertips, allowing it to feel weight, slipperiness, or temperature. These hands enable it to pick up shoes in the living room and neatly arrange them on a rack in just 30 seconds, or wipe down a long kitchen table in under 10 seconds using a cloth. Tesla Bot Gen 3's speed doesn't come just from its mechanical muscles, but from a powerful electronic brain. Inside its head is the FSD chip, the same type used in Tesla's self-driving cars, optimized to process hundreds of billions of operations per second. This chip handles all image input from the cameras, audio from microphones, and signals from sensors to make split-second decisions. That's why when it enters a kitchen, it doesn't need instructions to know what's a frying pan, a toaster, or a fridge. It has already learned from thousands of hours of factory data and real-life home video footage. In the test video, for instance, Tesla Bot enters the kitchen, sees a loaf of bread and a cup next to each other, and autonomously determines the next steps. Grab the bread, slice it, place it into the toaster, wait the correct amount of time, remove it, plate it, pour orange juice, and place everything on the table. The entire breakfast routine takes less than 2 minutes, something that usually takes a human at least 10 to 15 minutes. Most impressively, no buttons needed pressing, no reminders were given. It understood this series of actions as part of a morning routine. Another reason the bot is so quick and efficient is its remarkably accurate environmental awareness. With 8 hidden cameras around its head and torso, along with depth sensors and force sensors at every joint, it can calculate the exact distance from table to wall, spot a stray slipper under a chair, or even avoid knocking over a glass when wiping the table. This allows the robot to operate very naturally in tight spaces, an area where many traditional robots fall short. During cleaning tasks, Tesla Bot showcased staggering speed. When instructed to vacuum the living room, it identified dusty areas using light reflection and floor texture analysis, located the vacuum cleaner in the corner, plugged it in, adjusted suction power, and cleaned a 25 square meter floor in under 2 minutes. Normally, a person would need 10 to 15 minutes for this if done thoroughly. What's remarkable is that Tesla Bot not only works fast, it learns from what it does. Each time it pours a drink or sets a table, it records the time taken, notes the most efficient motions, and logs errors, like hand tremors or spills. After a few repetitions, it optimizes its movements and shortens completion time. In just one test day, The time it took to pour juice dropped from 6 seconds to 3.5 seconds by the third attempt. Even folding clothes, which started off clumsy, improved significantly over repeated tries. Unlike humans who tire after an hour of chores, Tesla Bot maintains consistent performance all day long. In an internal technical report, Tesla stated that Optimus can complete 150 tasks continuously over 6 hours without needing to reboot. In fact, at the factory, the Tesla Bot has been used to pick up tiny electronic parts under 3 centimeters in size, requiring extremely high precision, proving that it's far more than just a floor-mopping robot. All of this shows that if you're amazed by the fact that a Tesla Bot can work 5 times faster than a human, it's no miracle. It's the result of a highly agile humanoid body, AI software that learns and improves every second, and a sophisticated sensor system that allows it to understand every corner of the home. It doesn't just replace individual chores, it's starting to take over how work is scheduled and organized, like a true household manager. Elon Musk once said, "Sooner or later, Optimus will be able to do basically anything a human can do at home, just faster and better." And after this experiment, that's no longer a distant vision. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated, thank you. How does Tesla Bot prioritize and organize household tasks? One of the things that made the 24-hour robot-only home challenge so compelling wasn't just the speed, but the ability to handle multiple tasks simultaneously without a hitch. The Tesla Bot Gen 3 doesn't wait for instructions step by step, doesn't waste time fumbling, and most importantly, doesn't get confused even when the household is full of activity. It knows how to organize tasks like an experienced homemaker. Tesla equipped Optimus with the ability to receive complex chains of actions and reorganize them efficiently. For instance, if you left the breakfast table messy, the laundry is done, the floor is covered in crumbs, and the window hasn't been opened, Tesla Bot won't follow a rigid sequence. Instead, it may open the window first for light, start vacuuming the floor, tidy up the table while one hand is free, and fold the laundry last. This reorganization happens in seconds, with no human intervention. The robot can do this because it doesn't operate like conventional robots that only respond to commands. It functions as a full-fledged home task manager rather than just a helper. It remembers user habits, knows what tasks are typically prioritized each day, and learns over time to optimize the task order. This is what's known as contextual task planning, a capability still out of reach for most consumer robots today. Moreover, Tesla Bot can connect directly to the entire smart home ecosystem, which allows it to perform many tasks without even lifting a finger. For example, you don't need to tell it to turn on the lights or adjust the thermostat. As soon as it detects you've woken up, it can automatically turn on the bedside light, open the curtains, adjust the air conditioner, and start brewing coffee. This makes the morning routine seamless, with virtually no lag between tasks. If you have a vacuum robot, air purifier, smart speaker, or even a modern rice cooker, Tesla Bot can orchestrate all of them via IoT connectivity. That means it doesn't have to physically do everything itself, but uses existing devices to streamline actions, conserve energy, and boost overall efficiency. This sets it apart from robots that try to do everything manually. Tesla Bot's ability to prioritize is also impressive. In one test, it chose to wipe a water spill before folding towels because it recognized the risk of slipping. This decision-making comes from training on millions of real-life scenarios, allowing the robot to differentiate between urgent and deferrable tasks. On top of that, Tesla Bot can work for hours on end without fatigue, breaks, or distraction. Elon Musk once said Optimus Gen 3 can operate for 6 to 8 hours per charge and complete over 150 standard household tasks in that time. This means that in just one morning, it can clean the house, water plants, organize the living room, prepare snacks, sync home audio, and update connected devices without needing a recharge. A more concrete illustration is a 1-hour morning routine simulation in a household of 4. As soon as the alarm goes off, Tesla Bot turns on the lights, opens the curtains, checks the room temperature, and sets the air conditioning. While the family is still asleep, it prepares breakfast, fills the coffee machine with water, checks battery levels of mobile devices, and even brings clothes from the dryer to the bedroom. Over 20 small tasks are completed in just 45 minutes, more efficiently than a typical adult. Another highlight is personalization. Tesla Bot doesn't just do things correctly, but does them in the way users prefer. If you enjoy soft music while cleaning, like having breakfast after mopping the floor, or want the bathroom fan on before entering, it adapts to those patterns. This is not AI that only learns theory, it learns from real-life behavior and remembers tiny preferences like the usual dishwashing time or your favorite lighting temperature. This becomes especially valuable for families with elderly or young children. Tasks like checking whether doors are locked, switching on air purifiers before bedtime, or recharging the vacuum robot after use are all handled and repeated automatically. For elderly users, the bot can even track medication schedules, issue alerts when abnormal behavior is detected, such as sitting too long or talking less than usual. In that context, Tesla Bot is gradually evolving from a humanoid robot into a fully integrated home assistant one that knows what to do, remembers your preferences, organizes tasks intelligently, and works in harmony with all devices in the house. With AI and multitasking capabilities improving rapidly, handing over your household to a robot for 24 hours, as seen in the video, is no longer a futuristic fantasy. How has Tesla solved the challenge of durability and stability for its humanoid robot? Unlike humans who typically need breaks every few hours, the Tesla Bot Gen 3 can work continuously for extended periods without fatigue, distraction, or loss of efficiency. This trait is especially important if we truly want a robot that can replace a homemaker in real-world scenarios, not just serve as a technology showcase. This stability and endurance begin with Tesla Bot's advanced thermal management strategy. In conventional robots or electronic devices, continuous operation often leads to overheating, which causes performance drops or hardware faults. Tesla has addressed this by using a hybrid passive cooling system, with heat-dissipating chambers distributed across the shoulders, torso, and thighs. As a result, even after hours of operation, key components remain at stable temperatures, preventing the kind of thermal throttling commonly seen in phones or laptops. Additionally, Tesla Bot features what's known as dynamic load balancing, a system that automatically distributes workload across joints to avoid overloading any single limb. For example, if the right arm has just lifted a heavy object, the bot will prioritize using the left arm for the next task. If one part of the body has been moving excessively, the robot will adjust the motion of other components to balance the stress. This not only extends the robot's durability, but also cleverly mimics how humans naturally alternate muscle use to avoid fatigue. Another crucial factor is the simplification of its actuator system. Tesla avoids the use of complex gear trains commonly found in industrial robots and instead applies a less is more design philosophy. This means each movement involves less friction, lower wear risk, and higher long-term reliability. An Optimus unit can operate for weeks without maintenance, whereas Boston Dynamics robots often require recalibration or maintenance after just a few days of field training. Moreover, Tesla's internal tests have shown that Optimus Gen 3 can complete over 10,000 consecutive steps in a factory without significant posture deviation. For a human, 10,000 steps equals a full day's activity, but for the Tesla Bot, it's simply a sequence of precisely executed commands. This proves the robot is not just
almost everything in Optimus is new. There's not like an existing supply chain.
Elon Musk admitted. Tesla is placing a bold bet on its Texas factory to kickstart production of the Optimus robot, despite facing unprecedented engineering challenges. Aside from the AI system shared with Tesla vehicles, nearly every component, from motors and gearboxes to actuators, must be newly designed and built. If Texas becomes the birthplace of a global robot revolution, what will that mean for the future of manufacturing and human labor? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. Why can't Tesla rely on existing supply chains? Tesla's decision to manufacture the Optimus humanoid robot at its Giga Texas factory involves an exceptionally ambitious undertaking, developing nearly the entire technological and supply chain infrastructure from the ground up. As Elon Musk emphasized, almost everything in Optimus is new, with the sole exception of its AI computing system borrowed from Tesla's electric vehicle technology. The entire robot, from its actuators to sensors, drive units to structural components, represents a clean sheet design. This monumental task positions Tesla at the forefront of innovation, but it also presents enormous engineering, logistical, and strategic challenges. First and foremost, the lack of an existing supply chain for humanoid robots makes Tesla's endeavor unprecedented. In the EV market, Tesla was able to leverage and gradually build upon a partially existing automotive supply chain. However, in the case of Optimus, Tesla is stepping into completely uncharted territory. There are no mass-market suppliers for humanoid robot motors, actuators, power electronics, or robotic skeletons designed to operate in human environments. Each of these components must be either internally developed or engineered in collaboration with partners under Tesla's stringent design and cost parameters. The absence of mature suppliers significantly increases lead times, costs, and technical risks. The development of specialized drive units and actuators for Optimus is a prime example. Unlike cars, which use rotating wheels as their primary motion mechanism, humanoid robots require a wide range of movement with precise control. This means Tesla must design and test actuators that mimic human muscle groups while meeting requirements for strength, energy efficiency, compactness, and durability. These components must also be mass-producible at scale, which further complicates design constraints. Traditional suppliers of motors or actuators have never produced devices optimized for millions of humanoid robots operating in industrial and domestic settings. Tesla must therefore create its own standards. In addition, the lack of a robotic chassis supply chain forces Tesla to build entirely new manufacturing processes. The structure of Optimus must balance weight, cost, rigidity, and manufacturability, ideally incorporating lightweight yet strong materials like aluminum alloys or advanced polymers. But these materials, when formed into complex anthropomorphic structures, require specialized forming, welding, and joining techniques. Tesla is known for pushing the envelope in vehicle manufacturing with innovations like the Giga Press, and similar bold engineering approaches may be required to build Optimus's skeleton efficiently. Compounding these hardware challenges is the need to produce a new suite of power electronics tailored to humanoid robotics. Unlike EVs, which use large battery packs to power a few high-load systems, robots like Optimus rely on many small, low-latency circuits to drive a complex network of motors and sensors. These circuits must be compact, energy-efficient, and capable of handling real-time motion control. The required power modules, PCB layouts, and motor controllers are not available off the shelf. Tesla must design and validate them internally, iterating rapidly to ensure reliability, safety, and integration with AI systems. Furthermore, the AI computer that Optimus uses, although shared with Tesla's FSD system, is only one part of a much larger custom ecosystem of software and hardware integration. Every movement, gesture, and decision Optimus makes depends on the seamless interplay between AI perception, sensor fusion, real-time motor control, and edge computing. These subsystems cannot be borrowed from existing robotics applications. They must be built specifically for Tesla's vision of a multi-purpose, mass-market humanoid assistant, and they must be robust enough to support not just one or two prototypes, but thousands of units operating daily in demanding, real-world conditions. Another critical factor is time. Tesla is aiming to deploy thousands of Optimus units internally by the end of 2025, with mass production for external markets beginning in 2026. This extremely compressed timeline puts immense pressure on Tesla's R&D and manufacturing teams in Texas. From sourcing rare earth magnets for custom motors to establishing low-volume pilot lines for robot assembly, every piece of the supply chain must be coordinated with speed and precision. Delays in any subsystem, whether mechanical, electrical, or software, can cascade into larger setbacks for the entire program. The choice to localize production in Texas adds both benefits and challenges. On the one hand, It allows Tesla to co-locate its engineering, prototyping, and initial manufacturing teams within a single campus, streamlining iteration cycles and ensuring better quality control. On the other hand, it requires building entirely new facilities, workforce training programs, and supply logistics from scratch since Texas has no established ecosystem for humanoid robotics. Moreover, investing in Texas allows Tesla to take advantage of U.S. manufacturing incentives, including federal support for advanced robotics and automation. It also positions the company strategically to avoid global supply chain vulnerabilities, such as those exposed during the COVID-19 pandemic. However, these advantages do not eliminate the core difficulty. Tesla is essentially trying to create an industry before the market or infrastructure to support it exists. To mitigate risks, Tesla has taken a phased approach. As Musk mentioned, the initial robots will be used internally, primarily in Tesla factories. This allows the company to test functionality, gather data, and refine both hardware and software in controlled environments. The feedback loop from real-world use cases will be invaluable for optimizing future versions. It also reduces liability and PR risks compared to deploying unproven robots into customer homes or third-party workplaces too early. Nevertheless, this staged deployment does not reduce the fundamental complexity of developing Optimus. The demand for a modular, safe, affordable, and scalable humanoid robot requires solutions that go far beyond what exists in robotics today. Tesla is betting that its experience in vertical integration from battery packs to AI silicon will give it an edge. If successful, the company may establish a dominant position in what Musk has called a potential multi-trillion-dollar industry. In conclusion, Tesla's plan to manufacture the Optimus robot in Texas from scratch reflects its commitment to revolutionizing not just transportation, but the future of human labor and automation. The lack of a pre-existing supply chain for virtually all key components aside from AI demands bold engineering, enormous capital investment, and rapid innovation. By centralizing this effort in Giga Texas, Tesla seeks to control every aspect of the design and production process. But this ambition also comes with unprecedented risk. Will Tesla's vertically integrated model and aggressive timelines be enough to overcome the steep barriers ahead? The answer may well determine the future of humanoid robotics worldwide. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. How are the assembly and testing of Optimus carried out at the Texas factory? Tesla is gradually transforming the humanoid robot Optimus from a lab prototype into a mass-produced product, and the entire industrialization process is being implemented at Giga Texas. This is the first location where Tesla is trialing the complete Optimus production chain, from component development and software testing to real-world assembly. Unlike electric vehicles, humanoid robots require entirely new and complex production processes with many steps that have never been standardized in the manufacturing industry. The first notable challenge is that Tesla cannot rely on any existing supply chains to build Optimus. Elon Musk confirmed, "Almost everything in Optimus is new. There is no existing supply chain for any part except the AI computer and software." This means Tesla must build everything from scratch: lightweight skeletal frames, compact servo systems, flexible robot hands, and electronic nervous systems for signal transmission. Each component requires its own unique process of fabrication, molding, assembly, and testing, none of which resemble traditional car manufacturing. To serve production needs, Tesla has developed custom assembly lines for each core subsystem in Optimus. For example, the robot hand is assembled from over 27 moving parts, including a tendon-like cable transmission system. Tesla has created an automated installation process to ensure micron-level precision in each finger critical for tasks like opening door handles or grasping small objects. In a June 2024 live stream, Elon Musk revealed that this hand has achieved human-level precision in some repetitive tasks. Additionally, the legs and balance system represent one of the biggest manufacturing challenges. Optimus needs to walk flexibly, avoid obstacles, and maintain balance while moving around a factory environment. This requires each servo motor in the hips, knees, and ankles to deliver high torque while remaining compact. Unable to find suitable suppliers, Tesla designed its own actuators. These motors are currently produced in small batches and tested internally at Giga Texas before being integrated into full-scale production lines. Unlike cars, Tesla bots require perfect hardware-software integration at every step. A key part of Optimus production is the motion test post-assembly phase. Once a robot is fully assembled, engineers run dozens of tests to evaluate walking ability, object manipulation, balance control, and sensor response in real-world conditions. The data from these tests is used to update AI models in real time, and this cycle is now being conducted daily at Giga Texas. Another distinct feature is that Tesla is not mass-producing Optimus in the traditional sense from day one. Instead, it uses a method called supervised looped production. Each robot, after assembly, is deployed for real work inside the factory, for example, carrying light components or pulling carts while being closely monitored in real environments. This process helps Tesla detect software bugs, hardware weaknesses, and fine-tune the product before scaling up. Elon Musk said, "We expect to have thousands of robots working in Tesla factories by the end of this year, and the selection, training, and deployment all begin at Giga Texas." As of Q1 2025, Tesla has built over 100 Optimus prototypes and tested dozens of actuator configurations, aiming to accelerate design standardization. Production lines are being restructured to reach an annual capacity of 5,000 to 10,000 robots, a significant leap from current trial scales. At the same time, Tesla is developing high-automation testing equipment essential to reach the targeted unit cost of under $20,000 per robot, as announced by Elon Musk. What role does Giga Texas play in Tesla's global expansion strategy for Tesla bot production? Tesla is entering a new phase in the production of its humanoid robot, Optimus, with the goal of moving beyond small-scale trial manufacturing to ramping up its production lines to reach tens of thousands or even millions of units annually. This marks a critical turning point, transforming Optimus from a technological experiment into a large-scale industrial product. To achieve this, Tesla is implementing a series of systematic expansion strategies directly at Giga Texas. According to Elon Musk, Tesla aims to produce between 5,000 and 10,000 Optimus units per year, starting in 2025, once the pilot production process is finalized. This is an ambitious target, considering that each robot is a complex electromechanical system made up of hundreds of moving parts, sensors, motors, and computing components, most of which Tesla has developed from scratch. While only just over 100 prototypes had been produced as of Q1 2025, the pace of assembly line improvements at Giga Texas indicates that the company is accelerating rapidly toward mass production. At the core of Tesla's scaling strategy is the standardization of design for both hardware and software. During the trial phase, Tesla developed dozens of configurations for motors, arms, legs, and sensors in order to determine the optimal blueprint. Establishing a stable technical platform will enable the company to mass-produce the robot using highly automated assembly lines instead of assembling each unit by hand as was done during the prototype stage. In parallel, Tesla is also developing fully automated testing stations where each robot, once assembled, undergoes a series of movement, balance, and sensor response tests autonomously, minimizing labor and time. Beyond the technical aspects, Tesla holds a unique advantage in terms of organizational structure and infrastructure. Giga Texas is not only the assembly site for Optimus, it also serves as the real-world training ground for the robots. Each unit, after assembly, works actual shifts performing tasks such as pulling carts, moving materials, or executing simple line operations. Data gathered from these real-world deployments is continuously used to improve the robot's AI software. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.